Welcome to today's paper reading. Today's paper is titled, A Challenge to Long Context LLMs and RAG Systems, Summary of a Haystack. This paper, published on the AR14 preprint, presents a challenge to long context language models and retrieval augmented generation systems by Philippe, Laban and colleagues from Salesforce AI Research. The abstract discusses the capabilities of large language models, LLMs, and retrieval augmented generation, RAG systems, which can process millions of tokens. However, evaluating the quality of their outputs on long context tasks remains difficult, particularly in tasks like Needle-in-a-Haystack that lack complexity. The authors propose that summarization can be a key method for such evaluations. They introduce the summary of a haystack SummHay task, which involves synthesizing document collections where specific insights repeat across documents. The task requires systems to generate summaries that identify relevant insights and accurately cite the source documents. The authors have developed an automatic evaluation method that scores summaries on coverage and citation. They tested 10 LLMs and 50 RAG systems across 2 domains, conversation, news, and found that current systems significantly lag behind human performance, even when provided with an oracle signal of document relevance. The abstract concludes by suggesting that SummHay can also be used to study enterprise RAG systems and position bias in long context models, with the hope that future systems will match or exceed human performance on this task. The recent advancements in efficient attention mechanisms have significantly expanded the context length of large language models. Models like Claude 3 and Gemini 1.5 Pro can now process sequences of hundreds of thousands, or even millions of tokens. An alternative approach, retrieval augmented generation, RAG, proposes a pipeline method where a retriever selects relevant context dynamically, reducing the need for the generator to handle long contexts directly. Despite these advancements, there is a lack of direct comparison on common tasks. This work proposes using summarization as a testbed for evaluating long context models and RAG systems, addressing the challenges in current evaluation methods. In the field of summarization evaluation, existing research has primarily focused on short input, single document settings. Recent work has expanded this to long input evaluations, examining aspects such as coherence in book summarization and faithfulness across various domains. Additionally, studies have looked into content selection for book summarization and the effectiveness of a 2-step extract-evaluate framework. Moving to long context LLM evaluation, the needle-in-a-haystack concept was introduced to assess recall abilities in long contexts. Subsequent research has explored the impact of needle placement and variations involving multiple needles and modalities. Several benchmarks have also been developed to extend context length and address data contamination issues. Synthetic data, particularly at scales of 100K input tokens, has been introduced to challenge current models. Finally, in attribution evaluation, benchmarks have been created to study the ability of LLMs to ground their generation with citations. This includes the aggregation of 7 existing datasets in attribution bench and evaluations beyond document sources, such as knowledge graphs. Figure 1 outlines the process of synthesizing a haystack of documents, which involves 2 main steps, subtopic and insight creation, followed by document generation. This synthesized haystack is then utilized to benchmark LLMs and RAG systems on query-focused summarization tasks. The subtopic and insight creation step ensures that specific information units, or insights, are generated and categorized according to various subtopics. These insights are then included in the documents generated in the second step. The resulting haystack, composed of multiple documents, serves as a controlled environment for evaluating the summarization capabilities of LLMs and RAG systems. The figure visually represents this process, highlighting how the haystack can be used to assess the performance of these systems in generating summaries that accurately identify and cite relevant insights from the documents. In the haystack framework, the synthesis of haystack data involves synthetically generating documents to precisely control the distribution of information. This process begins with generating a list of potential subtopics around a central topic, ensuring each subtopic is distinctive and can expand into multiple specific insights. These insights are then used to create individual documents, with each document including a random selection of insights across subtopics, aiming for 750 words of content. By generating 100 such documents, a haystack totals approximately 100,000 tokens, providing a robust dataset for summarization tasks. Figure 2 demonstrates the evaluation process of a candidate summary against reference insights. Each reference insight is assessed for coverage by mapping it to a candidate bullet point, resulting in a coverage score of 100 for full coverage, 50 for partial, and 0 for none. The citation score is derived from the F1 score of precision and recall of the cited documents. The joint score integrates both coverage and citation scores, providing a comprehensive measure of the summary's accuracy and citation appropriateness. The evaluation protocol consists of 3 main metrics: the coverage metric, which measures the overlap between candidate and reference insights on a scale from 0 to 100, the citation metric, which evaluates the precision and recall of citations using an F1 score, and the joint metric, which combines coverage and citation scores. To ensure the reliability of these metrics, the authors and professional annotators achieved a strong inter-annotator agreement of 0.77 and a linking accuracy of 95%. To automate this process, large language models, LLMs, were tested, with GPT-4o and Gemini 1.5 Pro showing strong correlation with human annotations at a significantly reduced cost of $15.1 per summary. Table 1 presents the reproducibility and cost of manual and automated evaluation methods for the SummHay task. It highlights the coverage correlation, linking accuracy, and evaluation costs for both manual annotation and several automated models, including GPT-4o. The manual method shows a high coverage correlation of 0.77 and linking accuracy of 95%, but at a significantly higher cost of $325. In contrast, GPT-4o achieves a coverage correlation of 0.719 and linking accuracy of 89.2%, with a much lower evaluation cost of $26.1. This table underscores the trade-offs between human annotation and automated evaluation in terms of accuracy and cost-effectiveness. In the experimental settings, the study compares long-context large language models, LLMs, that access the full haystack directly with retrieval-augmented generation, RAG, systems that filter the haystack. For full-context summarization, various LLMs are tested, including Cohere's Command R and Command R+, Google's Gemini 1.5 models, OpenAI's GPT-4 Turbo and GPT-4o, and Anthropic's Claude 3 models. For retrieval-augmented summarization, RAG systems are evaluated to reduce the haystack input size. The benchmark results show that coverage scores, which measure the presence of expected insights in the summary, range from 36.2% to 81.4%. Citation scores, which account for precision and thoroughness of source attribution, improve with better retrieval. The joint score, which combines coverage and citation, is highest with the Oracle Retriever. Human performance is estimated to be significantly higher than system performance, with a joint score of 56.1, indicating potential for further improvements in RAG systems and long-context LLMs. Table 2 provides a comprehensive summary of the performance of human annotators, RAG systems, and long-context LLMs on the haystack task. The results are categorized into 3 metrics: coverage, citation, and joint scores. The full column represents the model's performance when the entire haystack is input, while other columns indicate different retrieval components used in RAG systems. The table ranks models by their Oracle joint score and includes the average number of words per bullet point for each model. Key findings include the wide range of coverage scores, the impact of retrieval quality on citation scores, and the overall joint scores that reflect the best performance of the models. Figure 3 illustrates the progress of human performance on the SummHay task over time. Participants show steady improvement, with both coverage and citation scores increasing rapidly in the first 90 minutes and then more gradually in the last 30 minutes. The citation score, measured as an F1 score, indicates that citation precision remains consistently around 80%, while recall steadily rises throughout the session. This data provides insights into how human annotators perform on the task, highlighting the learning curve and the balance between precision and recall. Table 3 presents the joint scores of leading language models, LLMs, in a full context setting, focusing on how document sorting affects performance. The models tested include GPT-4o, Claude 3 Opus, and Gemini 1.5 Pro. The study reveals that GPT-4o and Claude 3 Opus perform better when relevant documents are positioned at the bottom of the context window, while Gemini 1.5 Pro shows preference for documents at the top. A position sensitivity score is introduced to quantify the maximum absolute difference in joint scores between random ordering and top/bottom conditions, highlighting the model's biases. This research underscores the need for future systems to minimize sensitivity to document ordering, which is often arbitrary in practical applications. In discussing the task upper bound, the authors detailed their data pipeline and efforts to ensure dataset quality, including insight verification. However, they acknowledge that errors may arise from using LLMs and scaling data synthesis, making a perfect joint score of 100 unlikely. The authors also highlight simplifying assumptions made during data synthesis, such as generating Haystack documents independently without cross-references, which may not reflect real-world complexities. Additionally, they note that while they specify the number of insights for LLM-generated summaries, they do not control for verbosity, leaving potential trade-offs for future research. In this study, the authors introduced the SummHay benchmark to evaluate the capabilities of long-context language models and retrieval-augmented generation systems in summarizing large document sets. The benchmark requires precise summarization that accurately cites relevant insights to a query. The evaluation shows that current models significantly lag behind human performance, even in ideal conditions. The authors believe that SummHay will serve as a robust evaluation framework and encourage further research to improve model performance in long-context summarization tasks. Additionally, the study addresses ethical considerations, noting potential biases in the datasets and models used. The authors ensured fair compensation and anonymization of annotators, and verified the public release and proper permissions for all datasets and models utilized. Thank you for watching.